So, as a follow-up to our earlier conversation about finding the surface area of rectangular prisms, we're going to look at a couple other types of prisms because rectangular ones are not the only ones that exist. So as you see at the top, we're still talking surface area, but these notes specifically are going to be about triangular prisms, and they're exactly what they sound like. Instead of just all rectangular faces, what makes a prism is that it just has any sort of polygonal base. So that can be anything. We're going to see other types of these as well, but there's two identical polygonal bases, and then the rest of the faces are rectangular. That's what makes it a prism. So first and foremost, in order to find the surface area of a triangular prism, you must first find the area of each of the faces, and that's exactly what we talked about as we worked through rectangular prisms. We need to identify what shapes make up the figure and how many of them are identical, because as I said, right now we're talking triangular, but we will be looking at other prisms in the near future. So first, just pause and be able to reflect and look at this picture. We see this is a triangular prism. It has this face here, a triangular base, and even though it's not sitting on this face, this is the base, and there's one all the way back here that you can't even see the whole outline of, but if I can just kind of help you allude to what that back face looks like. Again, what makes it a prism is that these two are identical. So we have those two triangular faces, and then just to help us see the rest, we then have the rest of the shapes made up as rectangles. And so there's the one rectangle that you can't see, but that the shape is sitting on down below. We see this face here, and then there's one obviously on this side of the triangular prism as well. And so a lot of this unit really is just visualizing and being able to see some of these 3D shapes kind of apart from each other. So I'm going to teach you a couple just organizational tricks that I use when I have to break these shapes apart to find surface area. First and foremost, I would always find the area of the, in this case, triangular, and I'm actually going to use the word just for the purpose of these notes. It is a triangular base, but because we're going to look at other prisms, I'm going to call this just find the area of the polygonal base. So that, in this case, is a triangle. It could be a trapezoid, it could be a parallelogram, but find the area of the base first, and then you know that there's two of them. There's always going to be, so then multiply that area by 2. That's going to be our first step here. So because we're dealing with triangles, we know our area formula is area equals 1/2 times base times height. Maybe you don't have that memorized. Your blue formula sheet will be by your side through this part of our geometry unit as well. As we look at the picture again, we are looking for that perpendicular relationship. So our base and our height in this case is going to be 5 times 4.5. So when we calculate that, we have 5 times 4.5 got me 22.5, but then of course I have to divide it by 2 or multiply it by 1/2, and so I get my area to be 11.25, and we're talking feet squared. So again, that's just one triangle, but the most important part is just not to forget this second step. There's always going to be two polygonal bases, so I'm going to take that 11.25 and multiply it by 2 and get 22.5 feet squared. So that counts for my two polygonal bases that are triangles in this case. The second step then would be to find the area of each of the rectangular faces, because what makes a prism is that all of the faces that aren't the polygonal base are always going to be rectangles. And I think this part is the most difficult just to visualize, and so I have a little technique that I use. Feel free to use it as well. But if we can pause and just look up at the shape for a second, just make a couple observations, we see that this triangle, which is our base, has all of the rectangles faces are connecting my two triangular bases. I'm using these words back and forth. But that means that each side, and I want you to see this, each side of the triangle, so this side, and this side, all are one of the dimensions of each of my rectangles. Because I have a rectangle coming off of this face, one coming off of this side, and then one down here underneath off of this side. So my first just organizational piece, since we know that the area formula for any rectangle is just base times height, is to start myself off. Like, I know that because I have a triangle, I have 3 rectangles, one off of each of my sides of the triangle. And I know that my first dimension for each, whether you want to call it the base or the height, is each of the sides of the triangle. So up here we see the base of the triangle is 4.5 feet, so that will be my first dimension in this multiplication problem. Then we see these little tick marks on the other sides of the triangle, which are just telling us that those two sides are identical. And while there's no measurement up here on this triangle, this 6 feet is talking about that same dimension. So we know that each of those sides of the triangle are 6 feet. So those will be both coming off. There will be rectangles coming off of each of those 6 feet sides as well. And then the only other measurement on this rectangle or on this prism that's connecting the two is this 10 feet. This is going to be a dimension for all of the rectangles back on this line too, because that's the distance between the two bases. So once you identify the 3 sides, we just get to multiply each of them by that amount connecting the two bases. I mean, this hopefully will come to light a little more as we practice it a little more. But those are your 3 rectangles. And again, it's just base times height. So you can go through 6 times 10, we know to be 60 feet squared. So that's going to be the same for my 2 sides of that triangle. And then 4.5 times 10 is going to be 45 feet squared. So now we have all of the sides of the faces, and our last step then, as we were doing with rectangles, is to add them all together. So we have our 3 rectangular faces, which are 45 feet plus 60 feet squared plus 60 feet squared. And then we found that the area of our polygonal base was 11.25. You can either add that twice, or of course we already multiplied that by 2, so we can just add that 22.5 to account for both of those faces as well. So when we add all of those together, this is what's going to get us our surface area. So we have 60 plus 60 plus 45 plus 22.5 gives me a total surface area, my calculator is saying 187.5 feet squared. So there again is just my organizational technique, and just to recap those notes. Start with the polygonal base. In all of these examples we're going to look at, it's going to be a triangle. So start there and find that area first. Then, using each of the sides of the polygonal base, the triangle, start your rectangles based on that, and then multiply each of them just by the distance connecting the two. That distance will be the same for each. So on the back, I've got 2 examples that I'd love for you to try. I'm going to ask you to pause the video, work through this first example, and then once you feel like you've got an answer, unpause the video and my work will be up here, and we'll see if we get the same thing. So go ahead and pause the video, reconvene once you've got an answer for this first problem. So you see here just my work for the questions. I started up at the top here with the blue, and I'm just going to go shape by shape. The triangles where we started, we see that here's my perpendicular line, and I have 4 and 3 as those, so those are my dimensions, base and height for the triangle. So one triangle is 6 feet squared, but then both of them together, of course, are 12 feet squared. And then again, I know there has to be 3 rectangles, one coming off of each side of my triangle. So I started with 3, 4, and 5 because those are the sides of each of the triangles. And then this 7 is the distance connecting the two. So that's why they're all multiplied by 7 here in this row. Got each of those numbers, and then here I added them all together and got a total surface area of 96 feet squared. If you did not get this answer, go back and check, see maybe where we differed from each other. If you did, then I want you to pause the video again and work through that second example down below, and then check in with my work again. So in the second example, I went with the same strategy, started with that triangle, and our perpendicular lines here show us that the height is 3 and the base is 4. So each triangle is 6 feet squared, which I then multiplied by 2 to get that 12 feet, which really should be centimeters. And then again with my triangles, or my rectangles, I'm sorry, one needs to come off of each of the sides of the triangle. So I started, one has to come off of this, the 4, one has to come off the 5, and another one off the 5. So that's what this row in each of my rectangles stands for. And then my 15 is that side that's connecting the two triangles. So again, that's why all of them are being multiplied by 15 to get each of those rectangles. You add them all together, and I got 222 centimeters squared as my total surface area. So go back and check. Maybe if you made a mistake, make a correction to it. I'll be looking for this then tomorrow to see as we move forward in some more polygonal shapes.